Hello guys, I proudly welcome you to this quick video. In this video, I'd like to share with you a very super easy way of performing computations associated with regression models in general in the Rstudio environment. But then particularly this video, as far as I'm concerned, we shall be performing the illustration with the use of a logistic regression model. Logistic regression model has been chosen because of how wealthy and somehow complicated the formula turns out to be. By saying complicated, we don't really imply it being difficult or whatever. It is very simple, but then performing it handy using a calculator sometimes turns out very complicated. And I believe is that since we are in the R environment, R itself is a powerful scientific calculator that we can rely on for most of these R computations. So at the end of this video, I believe that we will all be able to turn into the R environment and compute outcomes associated with any class of regression modeling in Rstudio, and particularly in the regression model and the logistic regression, which we are interested in computing the odds ratio of model coefficients so that we can interpret the parameters, or let's say the coefficients of the variables, or the covariates. Then we can also use the knowledge in the video to compute the log odds of events, then odds of events occurring for subjects. Now we can do all these things with the use of the calculator because we have our formula in here. So but then at the end of the day, we can create functions in R that can automatically and efficiently and accurately do these calculations for us very easily. So this is a very simple video. Now let us just jump. So the main theme is how to perform computations easily and efficiently in R. Logistic regression was computations in R using functions. Alright, for instance, having estimated a model, if we are asked to determine the probability or the likelihood of an event given some values for the covariates, this is a function we'll be using because the R models the data that we feed in R, the outcome that comes are associated with this particular model. So at the end of the day, we sometimes we also be interested in estimating or calculating the probabilities of an event, because in some instances to the odd ratios, we've talked about that, and the log odds of events occurring, and then the odds itself of an event occurring. So the odds of an event occurring, if we want to get that, so that is what we have in the brackets here. We simply have to just take e exponent of each side, then we get our py1 minus 1 minus py being the general model of the logistic regression model. So by having that, if we are asked questions around it, we can create functions in R to have that computed easily for us. Okay, so now in this we have a fictitious data over here, so let us take note that the data here is fictitious, it is not real. So what is the odds definition? The odds of a person being COVID positive, then a dependent variable is COVID-19 positive. So 1 means the person is COVID positive, then 0 means the person is COVID-19 negative. Alright, so now let us run this our variables. So okay, so now we have our variables. Now we just want to check the accuracy of the length of each variable. So we say length of status times, so length, the product of all the length. If they are accurate, then they have to give us 10,000. So we run that, so we have 10,000 here, so meaning our variables are of equal length, which is good. Now we put them in a data set so that manipulations can easily be made. So we have disease is equal to this. So now this is the name of the data frame. Now also, so you can check your disease data frame here. So you can just type, you can view it. By this time I just want to show it in the console because it's a very little data set. So disease data frame is neatly created for us over here. Okay, now we had like to set female as a base level or benchmark. So if you are asked to set male, assuming we're asked to set male as a benchmark, it means that R should compute coefficients for males. Do you get it? Or assign 1 to coefficients of male. So in that case, male rather come in here and female rather come in here. So to understand this better, now female is a benchmark, so meaning we are setting females to 0, then males to 1. So We hold this, now we run, we summarize. So you can see that we have gender M here, so R has estimated the coefficient of the gender variable with respect to male, holding what female what constant, or female at the benchmark. So if you change it, you will see that it will now be estimated for female. So now it means that in your general model, that when it comes to the gender variable, if an outcome is associated with females, it means the value for the gender has to be 0. For males, it has to assume a value of 1. Alright, so now we have our model here. Now to move ahead in creating your functions, you just have to use these lines of codes to assign the coefficients in our model to some variables so that we can easily reference them in our function. So beta naught is assigned to the model first coefficient, which is what we have in here, and the second estimate for beta 1, beta 2, beta 3. So if in that order, if you have k independent variable, you do that. Now you can choose any name for your variable, the variables of the coefficient, but then it is very much easy to recall when you use beta naught, beta 1, beta 2, beta 3 in that order. Now we have confidence interval. Now let's jump straight to the core motive of this particular video. So now our function input is modeled with parameters. These are the parameters. Okay, so the first function we are going to create is a function to compute odds ratio. A function to compute odds ratio, and we know the odds ratio. So because in logistic regression we turn out to model the log odds, but we are interested in odds of an event occurring. So we simply have to just take e exponents of each side, and we get py or r minus py is equal to exp of this. So now it means that the odds of an event occurring given some set of covariates out here. So if we have some values for the covariates, now it means that we'll be able to determine the odds. Now by applying a little manipulations to the odds formula or the odds model, we can also get py, that is the expected value. Unlike linear regressions, simple linear or multiple linear regressions, whereby we model expected model means, here we are modeling probabilities. All right, so now we compute the odds ratio that we can easily interpret the coefficient. Now you can move ahead and do a naive interpretation by just using the coefficient that R has given, but then I wonder how your interpretation is going to be, because explaining the coefficient with respect to the log odds. So if you say the log odds of an event occurring will increase by this, no, I think that is a way going to be very confusing to our audience. So that's why we try to compute the odds ratio so that we can easily interpret the variable. So then we can say, so odds ratio, if we want the odds ratio for beta 1 is simply exp, because by then the e would have come to head this, and by the law of indices we can just put them together in multiplication. So we can say the odds of an event, the odds of a person being COVID-19 positive will be expected to increase by a factor of exp beta 1 is given that. So now how do we get that? Okay, so now the first function we're going to create is, we say odds, so odds ratio. So odds ratio is equal to function. Now this function will take in only one argument. So then inside here, now let us declare another variable. We say results. So what is the result? The result is exp of the x, because that is the odds ratio. So odds ratio of each coefficient will be given to us as exp of the coefficient. Now we say R should print and give us results. Okay, so we are done. Now this is a very simple function. This is a function 1, so we run it. Alright, so now for instance, let's say we want to find the odds ratio for the age variable. Age variable is beta 1. We have assigned it over here. So we simply come in here, then we say odds ratio of beta 1, then we run. So now this is the odds ratio of beta 1. So you can see it's very simple. Now if you want the odds ratio for beta 2, you simply say odds So you see your function is now here, so odds ratio for beta 2. If you have not assigned it to variables, then you can just type the number inside there. So that is the odds ratio for the height. So now we can interpret by saying the odds of a person being COVID-19 positive is expected to increase by a factor of 2.38 per each unit increase in a person's height. And you can see this one now, I mean, makes more sense, unlike if we had used the log odds. Okay, so now we can compute odds ratio for any. So let's say odds ratio, so odds ratio for beta 3. So let me turn to my console. So beta 3, because I've assigned a variable here. Now I'll run it. Then we have the odds ratio for beta 3 also here. Okay, so that is very easy. Now how about probability? So what is the probability? Because in logistic regression our outcome is now dichotomous. It assumes a value of 0, 1. So by 0, 1 it means that given any set of, we can just predict a person's probability of being COVID-19 positive, although we may not get equal probability, but then we may get something that is a way equal to 1 or far away from 1. Then we can actually make our conclusion. So how do we go about this? So let's say function to print likelihoods. So functions to print likelihoods, and I believe we all know where this particular function formula came from. So if we want to get probability given some set of covariates, so that's the expected value of a person being COVID positive, given that the person's age is this, height is this, and then also either is female or not. So now how do we do that? Now that is very easy. So let us turn away from our scientific calculator and use the R to do that. So we are just going to replicate this particular formula in R. So we say, so the function is going to be, let us call it likelihood, or we can say prob. So you can say prob is equal to function. So prob is equal to function. Now this function is going to take how many inputs? So it's going to take what we have. Now you ask yourself, how many covariates do we have in there? So we have what? 3. We have age, height, and gender. So you say x1, x2. You can use x, y, z, but then I prefer using x1, x2, x3. Okay. Now you open a curly bracket. So in here we can just say y is equal to, so we can just say y is equal to, now let us check it over here, exp. So we say exp, so now exp beta naught, so exp beta naught plus beta 1 times x1. So because that is how the calculation will be done, even if you are using a calculator. So plus beta 2 times x2 plus beta 3 times x3. Okay, now let's copy this. So we divide again by, so we divide by 1 plus what we've copied so far. So 1 plus this. So this is the expected value or expected probability function. So giving any values for the covariates, the probability of an event or a person being COVID-19 positive will give it to us as this. So now that you have this, you just say print. So the outcome, how much prints out what? The outcome, which is y. Now let us save our function. Okay, so we have our function what's in here. Now guys, we can confidently move on to compute any probability given any set of values for our covariates. So now let's say that we want to compute a probability of a person being COVID, given that the person's age is equal to 16. 16. The person's height is equal to 4 inch. Then let's say the person is a male, so the person is a male. Okay, so now what is the probability or the likelihood of a person being COVID positive given that age is this, height is 4, and then the person is a male? So how do we go about it? So this one, because we have the function, you simply move on to say prob. So you see the function here, so prob. Now, so you just move on to enter the values of the argument. So now x1, age is 16, so you simply put 16 here. So 16 here. Now height is 4, you simply put 4 here. The person is a male, 1. So you simply run it. And now they say the probability here this time around is 1. So let us try to change it for, let's say the person was a female. So we copy this. So the probability is 1. Now you can see we are getting exact probability because the data is fictitious. So let's say now it's 60. Let's use something higher. Let's say 6.6. And the person is a female. Let's run it. So now this time around, this will be the probability. So let's say the person was a male. So this will be the probability. Okay, so you can see this one is very much easy as compared to you using a calculator. So what's the probability of a person being 23 years of age who has a height of 4.2 and the person is a male? You simply run it, and now you get a perfect probability. So you get 1 or also over here. Okay, so now that is that. So given this, you can compute any sort of probability. You can try it out on questions that you've been solving in class or those ones that we have in the slides, and then confidently will get your answers. Alright, so now the last function we are going to compute is functions for log odds. So we are just doing variety of functions so that you'll be able to understand the concept. So what is the function for log odds? So log odds is given to us by this particular formula. So it is given to us by this formula. So that one is very much easy. So we simply come in here, then we say so log odd. So log odd is equal to function. So here again we have x1, x2, function argument being 3 here. Then we have the content of the function. So we can say m is equal to, so this time around, look at it, is just beta not beta 1 x1. So it's very much easy. I can even come in here and copy just what we have here. Then put it here. Alright, so now let us print. So we print m. Let us select the entirety. We just run. So error, repeated formal argument x1 on line. Okay, so let us check it out here. Alright, so now we have a challenge here. Let us fix it. Because these arguments have already been used, so let us make it x, y, then we say z instead. So in here we say x, y, then we say z. So z. Now let us select, let us run the line. Alright, so now we have it here. So now for instance, if you want to find the log odds of these same individuals here, so we can simply call the function log odd. So you can simply say log odd. So what is the log odd of the individual being? It's 16, 4, then 1. We run. So the log odd is 25.01712. So this is a log odd of a person with this set of values for the covariates. So now we can also say log. So meaning that if you have the function, now you can use it to do any sort of calculation. It's just a matter of you entering the values that will be given to you in the question, and off you are done. So just compute and you have your log odds over here. So we promised to making this particular video very brief, and we are ending right here, right now over here. If you are also got an alternative in doing this sort of calculations, we'll be very much grateful to have it shared. And also if you have a question or a suggestion, you do not hesitate to put it across, because we are all learning. Thank you very much for watching this particular video. Bye. All the best.